In this lesson, we are looking at graphing linear inequalities in two variables. So here are the different forms of your linear inequalities. So ax plus by plus c can be greater or smaller than 0, or greater or equal to, or smaller or equal to 0. So the inequality in the two variables x and y describe a region in the Cartesian plane. The ordered pair xy is a solution to a linear inequality if the inequality is true when the values of x and y are substituted in the inequality. And then when we graph it, we're going to shade in a region of it, and all those points in that region are going to satisfy that linear inequality. There's only a few things you need to remember that are different than graphing just a regular equation. So if you have a smaller than or equal to like this, you're going to draw a solid line. If you see strictly greater than or strictly smaller than, then you're going to draw a dashed line. So we're going to go ahead and try to graph our first example. We're given the inequality of 2x plus 3y is smaller or equal to 6. This or equal to sign means that we're going to draw a solid line. And we're going to use intercepts to graph the line for us. So we can ignore the inequality when trying to find our intercepts if we want to. So if we just think about the line itself, this is the equation for it. And if I want to put it into slope-intercept form, I would rearrange so I can solve for y. I would divide both sides by 3. So 2 over 3 is my slope, negative 2 over 3 is my slope, and 2 is my y-intercept. So I'm going to go ahead and graph our y-intercept on our xy plane. So 2 would be here. And then I need to find other points. So if my slope is negative 2 over 3, that means I'm going down 2 and then over 3. 1, 2, down 2, over 1, 2, 3. So this is my next point. I'm going to continue this pattern so I can find another point. So down 2, over 3 is another point. And then we can use a ruler and connect our dots, and we can create a solid line because our inequality is smaller or equal to. Looks something like this. It's not perfect right now. Okay, that's good enough. So that was the first step. Second step, we need to find the shaded area. What you're going to do is you're going to pick a point, any point, on either side of this graph so far. So I'm just going to pick a point, let's say 0, 0. Make sure you're picking a point that is on either side of your line, but it can't be on your line. Now we're going to check if our inequality is satisfied if we were to plug it in. So we're going to use our inequality that was given to us. 2x plus 3y is smaller or equal to 6. And then I'm going to plug in the point 0, 0 to see if it's true or not. So 2 times 0 plus 3 times 0. And if I were to simplify this, it'll be 0 smaller or equal to 6. This is true. When it's true, you're going to shade in the region where that point you picked lies. So we're going to shade in the region where 0, 0 lies. And that is going to be on the bottom portion of our line. So 0, 0 is here, that means we're going to shade in this entire region here. And then that would be our answer. In our next example, we are going to do something similar, but this time we're going to have a dashed line because we don't have the equal to sign with it. The first thing I'm going to do is get this into slope-intercept form. And then divide both sides by 5. So we're going to graph 2x, but when we do this, we're going to make sure we draw a dotted line or a dashed line instead. So we're going to have a point at 0, 0, then our slope is up 2 over 1, up 2 over 1, up 2 over 1, it continues. Just connect it through a dashed line, something like that. So that was step 1, where this was your slope. Our y-intercept was 0. I drew a dashed line for that. The next thing we're going to do is find the shaded region. And this time we can't pick 0, 0 because that is the part of our line. So we're going to pick another point. Let's just say negative 1, 1. And then negative 1, 1 is not a part of that line. So I'm going to use the inequality from the original question. And we're going to plug in our x value of negative 1 and our y value of 1 to see what we get. Now it's saying negative 15 is greater than 0. This is not true. So that means we're going to shade in the region that doesn't have that point. That doesn't have that negative 1, 1. So it can't be the left-hand side. It has to be the right-hand side then. This is the side that doesn't have negative 1, 1. And then we're done there. In our next example, we're going to write in inequalities to represent these graphs. First thing you're going to do is find the y-intercept, and in this case, it looks like it's at 1. Next, you're going to find the slope. And from a point, let's just say this one, let's say we went up to over 1 to get to the next point. So that means your slope is 2. Now we're going to write an equation and put it together. So we know it's in the form of y equals mx plus b. The m we found was 2. The b was 1. The next thing we're going to do is find the inequality sign because it's not an actual equation that we want to find. And we're going to do something similar by picking a point in the shaded area. And let's just say we pick the point 0, 2 because that's in the shaded area. We're going to put this into what we found in 3. But instead of putting an equal sign in between, I'm going to put a box because we're going to fill that in with the correct inequality later. I'm going to plug in the point 0, 2 in for my x and y. So 2 is my y, 0 is my x. So I'm looking at 2, some sort of inequality with 1. Well, for this to be satisfied, we have to pick 2 is greater than 1. and it can't be equal to either because we have that dashed line. So then we put it all together. So we have y is greater than 2x plus 1 as our final answer. Let's do this again with another example. Our y-intercept is at -2. Our slope looks like we went down 2 over 1. So down 2 over 1, which means we have a slope of -2. Now we're going to write the equation out in the form of y equals mx plus b. So y is equal to -2x minus 2. Now we're going to pick a point in the shaded area. Let's just say 0, 0 because that's in our shaded area. Now we're going to find that inequality. I just took the equation we had in theory, but instead of an equal sign, I put a box in there because I'm going to fill it out with the correct inequality sign. Now I'm going to put in that point 0, 0. So y is 0, x is 0. So 0 is something -2. And for this to be satisfied, 0 is greater than -2, and we're going to say equal to as well because we have a solid line in our graph. Now we're going to put it all together. Y is greater or equal to -2x minus 2 is our final answer. The last question here. Suppose we're constructing a tabletop using aluminum and glass. The most we can spend is $50. Laminated safety glass costs $60 for each meter squared, and aluminum costs $1.75 per feet. We want to choose the dimensions of the table, and we can choose also the amount of material used. We want to find all possible combinations of materials that could make this tabletop. So with this information, we have everything that has to do with cost. And it doesn't matter what the dimensions of the table are or the amount of material we used. So if we just talk about the cost alone, it's going to be $60 for the safety glass. So X is your number of laminated safety glass in meters squared, which means Y is going to be the aluminum in feet, the number of aluminum we have in feet. So that's 60x plus our cost for aluminum is 1.75 for feet. And all of this has to be less than or equal to $50. That is our equation. Now we're going to go ahead and graph this equation. And it might help if we put this into y equals mx plus b form. And then we're just going to use our calculator to simplify this here. We're going to get negative 34.3x plus 28.6. Now, I know it's going to be a little weird to graph because we are graphing with numbers and decimals, but we're just going to do everything approximately. So I'm going to go up by tens here. And then I'm going to graph the y-intercept, which is about 28.6. It'll be somewhere around here. And then our slope is down 34 over 1. It's going to look something like this. And we are going to use a solid line. Again, this is just going to be approximate because of those decimals, and that's fine. And then we're going to shade in the region where our inequality is satisfied. And it either has to be on the left side or the right side of our line. And we can do this using our test point to figure out which side. And I'm just going to use 0, 0. So 0 is smaller or equal to negative 34.3 times 0 plus 28.6. So 0 is smaller or equal to 28.6, and this is true. I'm going to shade in the side that has the 0 in it then, which would be this side. But be careful to state that as your final answer. Think about what we're actually calculating here. We are calculating the number of limited safety glass we have in meters squared. So this has to be a positive number. And then your y has to be positive too, because we're looking at the number of aluminum we have in feet. So x and y both have to be positive. That means the only region I'm going to consider then is the one that's bounded by 0, 0, and positive x and positive y values. So it's going to be this right here. And that is the only shaded region that we actually should have, not that. So that little blue region is our final answer. And it says find all possible combinations, and we found it by coloring in that region. So any set of points that sit in that blue region here is a solution. So 1, 1 is a solution, 2, 3 is a solution, like 1, 17 is a solution, and so on.